Here are the team members. Here are the instructions for both questions.
Assalamualaikum warahmatullahi wabarakatuh. My name is MUNEER, and today I want to talk to you about the instructions given on the schematic circuit in figure 1. If you look at the schematic circuit in figure 1, the instructions given was obtain the IV characteristic based on the diode given, which was the diode 1N4001 type. So if we look at those instructions, we must use Shockley equation. So based on the Shockley equation, we can identify which are the ID values and the VD values. For the diode 1N4001, the IS, which is the reverse bias saturation current, value is 5 microampere. So based on those values, we can then plot the graph on the graph paper so that we can obtain the IV characteristics given.
My name is RAFIZUYAIDI RAMLI. I'm going to talk about the simulation for this video. Okay. For the question 1, we are supposedly to assume the voltage source. So the value of voltage source we assume is 5 volt. So we run the simulation and got the IV characteristic for this question.
The next question is about the figure 2 circuit. So based on that circuit, we need to find the VDQ and IDQ, which are the operating points on the graph we must plot. So in order to do that, firstly we must simplify the circuit. So by using Thevenin's circuit, we can simplify the circuit and obtain the Thevenin's circuit. After we obtain those values, we can then use the load line concept, which is the x-intercept and y-intercept. Plot the load line on the graph, we can then get the intersection points, which is VDQ equals to 0.3 volts and IDQ equals to 14.5 milliamperes.
So the question 2 is the same as question 1. We supposedly to obtain the IV characteristic. We run the simulation as usually. But not to forget, we need to use IV analyzer as an indicator to get the IV characteristic graph for both questions.
Hi everyone, my name is QISTINA NASUHA, and I will continue our presentation with comparison between graphical method and simulation. So for the comparison in graphical method, it didn't have any breakdown voltage. Other than that, when the diode current is 0, then the voltage current is 0. In the table, from point -5 to 0, in VD, it will give result a constant value in ID. So for the comparison in simulation, when diode current is 0, voltage diode will give some value. Other than that, voltage source and resistance takes place. Moreover, reverse breakdown region occur. And lastly, in the table, from point -5 to 0, it will give result constantly equates value in ID.
Hi, Assalamualaikum. My name is HANISAH. So today I will cover 2 main points about our group discussion result. Firstly, breakdown region in IV characteristic. Our group has discovered that it only happened at simulation instead of manual calculation. This is because there is no voltage source involved in the Shockley equation. That's why when a voltage source applied is bigger than breakdown region, the current will drastically drop. Second, our group has noticed about the different value of operating point, which is Q point, in manual calculation and simulation, which is in manual calculation we get 0.43 volts and 40.5 milliampere for the current, but in simulation we get 1.67 volts and 5.4 milliampere for the current in simulation. These two differences occur because the involvement of voltage source and resistance that give a big impact to the graph that we obtain.
So the contents of our report consists of introduction, methodologies, result and discussion, diode application, self-reflection and also conclusion. Let's see more in our report later. Bye!